So I want to evaluate this. Well, I'm going to go about this exact same way that I've done it before. I'm going to take this part, I'm going to work with this first, treat it as its own separate integral, and then whatever I get as a result, I'm going to go ahead and put in the second integral. So I need to integrate from a negative square root of 1 minus x squared to square root of 1 minus x squared of 2x squared y dy. So when I do this, I'm going to end up getting x squared times y squared, because this could be y squared over 2. The 2 is going to cancel. Evaluate from a negative square root of 1 minus x squared to a positive square root of 1 minus x squared. So the x squared is a constant, so I'm going to leave it out there. X squared times this squared is simply 1 minus x squared minus this squared. Well, this is also going to be a 1 minus x squared. So this is actually going to be equal to x squared times 0, which is 0. So there's really no reason to even continue. But if you really wanted to, it would be 0 to 1 of 0 dx, which equals 0, and you're done. So the volume of this between the xy axes and this surface, with this region being on the xy axis over x equals 0 to 1, is actually going to be 0. So if we think of this as volume, some of the volume will be positive, some of the volume will be negative. Obviously, there's no such thing as negative volume, just like if we integrate a function that has positive and negative regions, this would be a negative contribution, this from here. This would be a positive, this would be a positive, this would be a negative, this would be a positive. So we don't actually think of this as area, negative area, but if this was some type of financial function, this would be like profit and loss. Well, the same sort of thing in 3 space. We don't really think of negative volume for something below the xy plane, but the contribution is negative.